Section 8.5, to solve problems involving angles of elevation and depression. We've all been in a situation where we've been standing and looking straight ahead, and then we have noticed something up in the sky. Here we have a hot air balloon. So my line of sight, which is the horizontal line of sight, is straight out ahead of us. But as I view something in the sky, I would then look up and create a line of sight toward that object, here a hot air balloon. That would create an angle from my horizontal line of sight to the line of sight to the object. That angle is called the angle of elevation. That is to sight an object above the horizontal line of sight. And notice what I've created is an altitude from that object, which is the hot air balloon, down to the horizontal line of sight. What that creates is a triangle. And since I said altitude, we know that that is a perpendicular segment from the vertex to the opposite side. And when that is created, we now have a right triangle that we can do trig ratios on to find missing angles and sides in this figure. In this diagram, the x degrees is the angle of elevation. The most important thing to remember is this. The angle of elevation is always created by a horizontal, not a vertical line. If I would take a look at this diagram, I have three angles. We know the right angle. The two acute angles is the ones we have questions about. One would have to be the angle of elevation, and it is defined as the one that is always next to the horizontal line of sight, not the vertical line. Again, let's remember, the angle of elevation is created from the horizontal line of sight to line of sight to the object we're viewing. If I would be standing above an object and I have a horizontal line of sight, and then I would look down to create a line of sight to the object below me, that would give me an angle of depression. And this is to sight an object below the horizontal line of sight. Again, in this diagram, x degrees is the angle of depression. And again, the important thing is, the angle of depression is always created by the horizontal line, not a vertical line. Again, I have the horizontal line of sight. I look down and I view the boat from my line of sight to the boat, and that generates my angle of depression. I drop an altitude, and that creates my right angle. Again, I have two acute angles, but my angle of depression cannot be against the vertical line. In our first example, we're asked to describe each angle as it relates to the situation in the diagram. Here I have a cliff above an ocean floor. I have a boat on the ocean, and from that boat, if they would view the horizontal line of sight, that would go to the shoreline, and they view an object above that horizontal line of sight. Therefore, I have an angle that is created, angle 1. And angle 1 is an angle of elevation because it is created from the horizontal line of sight to the line of sight to the object we are viewing. Therefore, angle 1 is an angle of elevation. Angle 2, again, is if I'm standing on the top of the cliff and have a horizontal line of sight, and I view down to the boat, I have an angle created from the horizontal line of sight to the line of sight to the object I'm viewing. That is called an angle of depression. Therefore, angle 2 is an angle of depression. Notice in our first two instances that each angle is formed against the horizontal line of sight. Angle 3 is adjacent to the horizontal line of sight, but also against the vertical line. So angle 3 is just another acute angle in a right triangle. This is not used for any reference material to solve problems in our diagram. So angle 3 is neither. On this example, the sun casts a shadow of a tree. If the shadow is 42 feet long and creates an angle of elevation of 37 degrees with the ground, how tall is the tree? We're given a tree. And a sun will generate a shadow of the tree, and we know from the diagram that the shadow is 42 feet long. And what we want to do is to drop an altitude from the top of the tree to the ground. Altitude creates a 90-degree angle. We're also given in the problem that I have an angle of elevation with the ground of 37 degrees. We want to know how tall is the tree, and we can let that value be x. And we're given a right triangle. Therefore, what I can use is our tangent ratios. The ratios are either going to be sine, cosine, or tangent. Remember, the sine of an angle is going to equal opposite over hypotenuse. The cosine of an angle is going to equal adjacent over hypotenuse. And the tangent of an angle is going to equal opposite leg over the adjacent leg. And in this problem, I'm given an angle and I'm given each leg, or at least I know the value of one leg. I need to determine the other leg. Therefore, the only trig ratio, sine, cosine, or tangent, that deals with both legs is tangent. Therefore, I'm going to have the tangent of 37 degrees equals, and here, if I identify the parts of the triangle, this is my adjacent leg, and x is my opposite leg. Therefore, this will be x over 42. Again, I create a ratio on the left side. Cross product gives me 42 tan of 37 equals x, the height of my tree. Now I just plug this into the calculator and get the value for the height of the tree. And when I plug the expression 42 tan 37 into my calculator, I get 31.649 feet. If I round out to the nearest tenth, the height of the tree is equal to 31.6 feet. My next example, a ladder 22 feet long leans against a building and forms a 58-degree angle with the ground. How high does the ladder reach on the building? In this problem, we have a building, and we have a ladder that extends from the ground to the building. We know the ladder is 22 feet long, and we know the angle generated from the ground to the ladder is 58 degrees. We want to determine how high up does the ladder reach on the building. If I identify the parts that I know and don't know in my figure, I have an angle, I have the hypotenuse, which is 22 feet, and I need to determine the height of the ladder is off the ground on the building. That is represented by x. Using 58 degree as my angle, I know that x is my opposite leg. Now I have to determine what trig ratio has hypotenuse and opposite leg in its ratio. That would be the sine function. So here I have the sine of 58 degrees equals opposite, which is x, over the hypotenuse, which is 22. I generate a ratio on the left side. Now I use the cross product, which will give me 22 sine of 58 equals x. Then I can use my calculator, substitute the expression in, and determine the answer. When I substitute the expression into the calculator, I get 18.657 feet. Therefore, when I round to the nearest tenth, the height the ladder reaches up the building is x equal to 18.7 feet. In this example, Stephanie stands on the edge of a cliff 205 feet high and sights a sailboat 1,025 feet from the base of the cliff. What is the angle of depression formed by Stephanie? Here we're given a cliff, and we know that cliff is 205 feet high. And we have Stephanie, who is standing on the top of it. She's looking straight out. That's her horizontal line of sight. She creates a line of sight to a sailboat below in the ocean. And that will generate, with the horizontal line of sight, an angle of depression. We know that the boat is a distance away from the cliff, which is 1,025 feet. And she generates an angle of depression from the horizontal to the line of sight to the boat, which we don't know what that is, so it's x degrees. I create an altitude from the horizontal line of sight to the boat. Now, there's two ways to look at this. One is to realize that I have a rectangle. Therefore, I know that opposite sides are congruent. So this is 205 feet. So this segment is 205 feet. And again, this is 1,025 feet. This is 1,025 feet. Another way to look at it is that this is a parallelogram. Therefore, I know that these are alternate interior angles and they are congruent. In either case, my angle of depression is always against a horizontal and never against the vertical. So in each situation, I can still find the value using the same trig ratio because it's going to set up the same exact way. Notice if I identify the sides based on the angle, 205 is my opposite leg, while 1025 is my adjacent leg. And that is the same for the lower triangle. 205 is my opposite leg, 1025 is my adjacent leg. Now, I have to identify the trig ratio that uses opposite leg and adjacent leg, and that would be tangent. So I have the tangent of x equals opposite, which is 205, and again, it doesn't matter which triangle I use, and adjacent, which is 1,025. Now I'm finding an angle. So I need to use my calculator. I use second tangent because I'm finding an angle, and then just enter my ratio, which is 205 over 1,025. And after pressing second tangent and entering the ratio 205 over 1,025, I'm going to get an angle of 11.3 degrees. Therefore, when I round to the nearest degree, the angle of depression is 11 degrees. In my last example, a small plane's altitude is 724 feet when it is 1 mile from the landing strip. What is the angle of descent to the landing strip? Or what is the angle of depression? I have a small plane and it is looking for a landing strip. It has a horizontal line of sight, and then it sights its landing strip. I know that the altitude of the plane is given to be 724 feet. I also know that the plane is 1 mile from the airport. 1 mile is 5,280 feet. What they want to determine is the angle of descent or the angle of depression. Now, using that angle, I need to identify the sides of the triangle. Here I have an adjacent leg, and here I have an opposite leg. Now I determine the trig ratio by the parts of the triangle, opposite and adjacent. That would be tangent. Tangent of x degrees equals opposite, which is 724, over adjacent, which is 5,280 feet. Remember, I need to have my units to be the same for my measurements. Here I have feet and feet. Now, to find the value of x, I need to press second tangent and enter the ratio 724 over 5,280. I do that because I'm finding an angle. And after entering that into the calculator, I get approximately 7.8 degrees. And when I round 7.8 degrees, I get an angle of a descent approximately at 8 degrees.